Hey guys, welcome to day 25 of 100 Days of Code. So today we're going to be learning CSV files, so not just text files as we saw in yesterday's lessons, but we're going to be working with data files and we're going to be analyzing that data with a library called Pandas. This is one of the most popular Python data analysis libraries, and we're going to get to grips with how we can use it to start getting some insight into our data. By the end of the day, you're going to be building an educational and interesting game, which gets you to guess and learn all of the states in the US. And the inspiration comes from a quiz on Sporkle, where it has a map of all the states. It's all blank until you start guessing some states, and then you keep going until you've managed to get all 50, or like me, you get stuck at 30 out of 50. This game tests you on your knowledge of the names of the 50 states in the US. So, for example, if I go and add another state and I hit OK, then that name appears on the map at the location of the state. The aim of the game is to remember all of the names of the states and to name as many of them as you can. So I managed to get to about only 30. But I've never lived in the US, so my knowledge just comes from watching TV shows and general knowledge. But if you're from the US, then you're probably going to do a lot better than me. So this is an interactive and educational game that I think that you're going to enjoy playing. So once you're ready, head over to the next lesson and let's get started learning about how to work with data files. When I was really young, I remember a piece of homework that I had to do for geography in school, and the teacher asked us to basically watch the weather report every single day on the news and note down what was the temperature, what was the weather condition of that day, and then we would end up with the weather conditions and temperature for the previous week. Now, at the time, it was the point in time where a lot of teachers didn't actually really know what the internet did. So I realized that I could actually just wait until the day before I have to give the homework in, go onto the internet, find the weather conditions for the previous 7 days, and then write it out, instead of having to watch the weather forecast every single day. So I don't know what that says about me, but if you're somebody who enjoys taking shortcuts in life and refuse to do work that can be done by computers, then you are in the right place. Learning Python is definitely the way to go. So inside Google Sheets, which you can access by going to sheets.google.com, I have created a new spreadsheet of the days of the week and the temperature of each of those days in Celsius, and also the weather condition on those days. This is a replica of that homework from many, many moons ago, but we're going to be working with this data to learn how we can read data files and then analyze them and how we can do lots of things with it. So the first thing I want you to do is to head over to the link in the course resources, which will take you to this spreadsheet. And then once you've got it open, then go to File, Download, and I want you to download it in the comma separated values or CSV format. And you should end up with a file like this. Now I want you to rename this file so that it's just weather_data.csv. And then I want you to create a new PyCharm project, which you can call anything you want. I've called it day 25, and also create your main.py. Now I'm going to drag my weatherdata.csv into my folder day 25 and click refactor to move that file into my project folder. Now at this point, PyCharm recognizes that this is a CSV file, and it asks you whether if you want to install some plugins to make it easier to view this file. Now at this point you can click cancel because we want to view the data as the raw data, which is in this CSV format. Now, CSVs are a very common way of representing tabular data, so data that fits into tables, like a spreadsheet. And CSV, as you've already seen, stands for comma separated values. So that's why when you look at the data, you can see each row here is a single set of data, and each piece of data is separated by a comma without space. So we've seen how we can open files, read files, write to files. As a challenge, I want you to go ahead and open up this weatherdata.csv file inside your main.py and add each line of data into a list which we'll call data. Pause the video and give that a go. All right, so we know that we're going to need to open the file, so it's stored inside the same folder as our day 25. So we can just use a relative file path to tap into this weatherdata.csv, and we're going to save this data as a data file. And then we're going to get the data by reading this data file. So data equals data file dot read. And not only are we going to read it, we're going to use read lines, which we know will take each line in this file and turn it into an item in the list. Now, if I go ahead and print my data, then you can see I've got this list now where each item is a row in that list. But as you can imagine, it would be pretty painful to work with the data, and they're still separated by commas. It would take a lot of cleaning to actually be able to extract each column and each row. So what can we do instead? Well, there's actually an inbuilt library that helps us with CSVs, because Python is a language that's used really heavily for data processing, data analysis. There's a lot of great tools for working with tabular data, like our weather data. First, we're going to import the CSV library, and then we're going to again open up our file, weatherdata.csv, as our data file. And then we're going to use this CSV library, and it has a method called reader, which takes the file in question, which has already been opened. So this is going to be our data file, and it can read it and output the data. So now let's go ahead and print this data and let's see what we've got. You can see that it's created a CSV reader object. This object can be looped through. So if we wanted to get each row inside this data, we can say for row in data, go ahead and print each row. And once you've done that, you can see it's taken each of the rows inside our weatherdata.csv and separated out each item into a single value. So for example, on the Monday row, we've got the Monday as a string, we've got the temperature as a string, and also the condition as a string. So now it's much easier for us to work with this data. Using what you know about Python lists, I want you to create a new list called temperatures. And this list is going to contain all of the temperatures that is inside this weatherdata.csv, like this 12 degrees, 14, 15, and it's going to be in the format of an integer. I don't want to see it as a string with quotation marks around. It should be a pure number so that we can work with it more easily. So this is your challenge. Pause the video and see if you can extract all of the temperatures from this file into this new list. All right, so when we printed out each of the rows, we can see that we've created several lists where each list contains an entire row of data from our weather data CSV. If we wanted to get the temperature, then it's going to be the item at index 1 in that list. For example, if we wanted to get the Monday temperature, then all we have to do is to tap into each of these rows and get the item at index 1. If I go ahead and print this, then you can see we get all of the temperatures, but also the label for that column. So if we want to exclude that label, then all we have to do is use an if statement and check if row at index 1 does not equal temp, which is the name of that column label. Then we're going to tap into our list of temperatures and append this row at index 1, which is going to be a temperature number. So now, after we've done the entire for loop, then we can print out our list of temperatures. And if you take a look, you can see we've now got a list of all the temperatures, excluding that column title, but they're all in the format of strings. So if we want to convert that into an integer, then all we have to do is wrap that around an int. Challenge. Now, you can of course separate out this line into many more lines, but I think this should make enough sense for you at this stage. While CSV is the inbuilt CSV reading and writing library, notice how much faff was involved in just simply getting a single column of data. What are we going to do if we have more data, more complex data with way more columns, way more rows, and we want to do more interesting things with it? This is going to be quite painful to work with. This is the point where we want to get the help of some pandas. Not these kind of pandas. As cute as they are, they're not going to help us with our data analysis. But instead, I'm talking about the Pandas library. And this is a Python data analysis library, which is super helpful and super powerful to perform data analysis on tabular data like the one that we have. In order to work with it, we have to import this library. But because it's not inbuilt, you'll need to install it into your project. So the shortcut way of this is simply just to type import pandas, and then once you see the red line, go ahead and hover over it and then click install package pandas. And then you can watch the progress down here. Now, while that's installing, I want to quickly introduce you to the documentation for this library. It's really well documented and it's really powerful, so it has a lot of things in the documentation. If you head over to pandas.pydata.org and then click on documentation, then you'll be able to see all the things that you can do with it. So there's a API reference, there's a quick getting started guide, as well as a user guide on the key concepts of pandas. When you're using a new library of any sort, a good idea is to take a look at their getting started guide if they have one, because it tells you how you can install it and a number of questions that you might have. For example, what kind of data does Pandas handle? Or how can I read and write tabular data? And it's actually done really, really well. So if you have a moment, take a quick look at this page. And once you head back to PyCharm, your packages should have installed successfully. Now, once we've installed our pandas, you'll see that it's still gray because we're not using it yet. If we want to use pandas, all we have to do is say pandas dot, and in our case, we actually want to read our CSV. So we can say read CSV, and inside this method, you can do lots and lots of things, as you can see by all of the attribute names, but most of these are optional. The only one that is not optional is the path that leads to the CSV file. So if we get hold of our weatherdata.csv, then we can read that CSV using pandas. So notice how we don't have to open the file as a data file or use CSV reader. It's one step and you're done. So now we've got hold of our data. And if I print out the data, you can see how beautifully formatted it is. It's being printed out as an actual table. It's got the column headings on top of each of the columns, and each of the rows gets given an index so that we can more easily identify how many records we have and where each one is. If we wanted to think about that previous task that we tried to do, where we just try to get hold of a single column of data from this table, then using pandas, it is literally as easy as saying data and then square brackets and then the name of that column. So in our case, it's temp. And now if I go ahead and print this out, you can see it's basically already identified the column and it's printed out all of the data in that column. So the really smart thing that Pandas is doing here is it takes that first row to be the names of each column, and it automatically knows how to find the data when you just specify the name of the column like this. So 3 lines versus 8 lines. and we get better formatting. It's no wonder that most Python developers, as soon as they encounter a CSV file, they will start using Pandas to work with it, no matter how simple the task or project. So that was a quick introduction to CSV data, working with CSV data, and how to get started using Pandas. In the next lesson, we're going to dive deeper into this library and see all of the common things that we can do with Pandas. In the last lesson, we got started using Pandas. We installed the library and we imported it to read a CSV file. And then we used that file to get hold of a column which has been automatically identified as soon as it read this data CSV. So what exactly are we dealing with here? Well, one of the most useful things I find is to do type checks on any of the objects that I'm working with from a new novel library. For example, we can use the type method to check what exactly is the data type of this data that we're getting back from Pandas. So if I go ahead and print this one and comment out this second line, then you can see what we're getting is what's called a Pandas data frame object. In the package overview, they talk about the two primary data structures of Pandas, series and a data frame. A data frame is kind of the equivalent of your whole table here. So every single sheet inside an Excel file or inside a Google Sheet file would be considered a data frame in Pandas. Now, what about this second part here, where we've gotten hold of one of the columns in our data frame? If I do a type check on this object and I hit run, then you can see this is a Pandas series object. The series is the other super important concept in Pandas. And the series is basically equivalent to a list. It's kind of like a single column in your table. So the temperature column would be a series, the condition column would be a series, and the day column would also be a series. So once you've grokked this idea that the whole table is basically a data frame in Pandas, and every single column is a series, kind of like a list in Pandas, then you're pretty much half of the way there to understanding how this library works. Now, if we go over to the API reference, you can see that this is basically a list of all of the things that you can do with Pandas. And it is a long list of things. But let's take a look at those two core classes, the data frame and the series. So if we go to the data frame, you can see that it has things on how to construct a new data frame, how to get hold of the index, how to get hold of the column labels, and there's a whole bunch of attributes that you can tap into, as well as many methods. For example, if we take a look at this section on serialization IO conversion, you can see that you can actually convert a data frame to various different file types. You can convert it to an Excel file, you can convert it to HTML, you can also convert it to a dictionary. So if we click on this, this takes us to the actual documentation on how you would use this method. And if you look at the basic Python documentation versus Pandas documentation, you'll see why this is so much better. It lists out all of the possible parameters. It gives you examples on how you can use each of the methods, and it's also got some related methods that it thinks that you might want to take a look at. So let's use this method, and what we're going to do is I'm going to get my data and I'm going to call to dict, which is going to convert it into a dictionary. So let's call that data dict equals data to dict. And then if we print out our new data dictionary, you can see that Pandas has taken our table and taken each column of the table to create a separate dictionary for each of the columns. So we've got day, temperature, and condition, and we can now work with this as if it were a real dictionary. Now, if we take a look at the series data type, and you take a look at the conversion section for this type of data, then you can see that you can actually convert each of the series to a list if you want to be able to work with it just as you would with any other list. So we saw that we can get our data and then get the temperature column And this, when we printed out the type, was a series. So we can get the series and then call to list, and this will turn this data series into a Python list. So let's call that temp list, and let's go ahead and print it out. This would be a list of all the temperatures, and this is now converted into the raw Python data type. So we can do all of the things that we can do to a Python list, like, for example, we could check its length. So here comes another challenge for you. Given what we've spoken about so far, can you figure out if you can work out the average temperature in our column of temperatures? So remember, you can always Google if you don't remember how to calculate the average of something. So pause the video and give that a go. All right, so we know that we can get a list of all of the temperatures in that list. And we know that Python has a built-in method called sum. So then we can get the sum of all of the temperatures in our list of temperatures, and then we can divide it by the length of the temp list. The sum of all the values divided by the number of values gives us the average, which is also known as the mean. And so if we print this out, then you can see the average temperature over the week was 17.4. Now, an alternative way of solving this challenge is maybe you took a look through this list of methods, and you might have come across some of the computations and statistics that you can do with your series in Pandas. Now, one of those methods is the mean. So you can actually get rid of all of this excess work and take our data series, which is basically the column of data under the heading temp, and simply call .mean on it. And now if I print this out, you'll see it's the same result as before without a lot of the extra work. In addition to the mean, you can get other things like the median or the mode and a whole bunch of other things just by calling the right method on the data series. So here's a challenge for you. I want you to get hold of the maximum value from this column of temperatures by using one of the data series methods. Pause the video, have a look at the documentation, and see if you can complete this challenge. All right, to get the maximum value, we're probably going to need this max method. So we call this method in the same way as we did before, which is get hold of the data series. So our entire table is stored in data. And then we can get the column under the heading temperature. So this is now a data series. And then we can call that method max on it. And if we print it out, then you can see what we're getting is 24. So the highest temperature was 24. So you've seen that when we're working with Pandas, it's really easy to get hold of data in a particular column. All we have to do is just take the data frame, use a set of square brackets, and then specify the name of the column, which it takes by default as the first row of the data. So the day column, the temp, the condition. So if I want to get hold of all of the conditions, then I would say data condition. And if I go ahead and print this out, you can see it gets hold of all of the weather conditions and selects that column to print out. Now, an alternative way to using this square bracket notation, where you have to be careful about the string you use here, it has to match the name of the column exactly. Another way that you can work with the columns is simply by calling data.condition. And the fact that this code is valid at all means that Pandas behind the scenes has taken each of these columns and each of the headings and converted those headings into data.day. And if I print that out, you can see it's actually going to be exactly the same as doing it like this. So it's up to you which method you want to use to select the columns, but be aware that if your column name has a capital C, for example, here, then your key has to be a capital C, and also your attribute has to be a capital C. So effectively, when you're using a data frame like this, it's almost like you're treating it as a dictionary, and you're pulling out each column by the key. Now, when you're using the data frame like this, then you're kind of treating it more like an object. You're saying data.attribute, and you get hold of the data in that column. So I'm going to restore everything to lowercase because I find it easier to read the code. But the next thing I want to show you is a little bit harder, which is how to get data which are in the rows of our data frame. If I wanted to get hold of the entire row of data for where the day is equal to Monday, then the way that I would do that in Pandas is firstly get hold of my entire data table, and then inside that data table get hold of the column that I want to search through. So I'm going to search through the day column. So I can use data.day or data square brackets day. Both will work the same. But once I've got the column, then I can say, well, where inside that column, I want to check for the row where the value is equal to Monday. This is basically going to return my row that I want. So I'm going to print this out, and I'm going to comment out all of the previous code other than the place where we created our data frame. And then I'm going to run my code. And you can see it's pulled out that correct row where the day is equal to Monday. And it's given me all of the rest of the data for that row. So here's a challenge for you. Can you figure out how to pull out the row of data from our weather data where the temperature was at the maximum? So which row of data had the highest temperature in the week? Pause the video and give that a go. So we know that we can get the maximum temperature in the temperature column just by using this code. Now, you can either use this method where you say data square brackets temp, or you can use the attribute.temp, which is the code that I prefer. I don't like writing a lot of strings if I can avoid it. In this case, we're checking to see which row inside our column of temperatures is equal to the maximum temperature. We would say data.temp is double equal to data.temp.max. And then we're going to get our data and access the row that fits that criteria. Now, if I print out this row, then you can see it was the row for Sunday, where the temperature was 24 and the condition was sunny. Essentially, when we get our data frame and then we use some square brackets, and inside those square brackets, if we only put the name of our column, day, temp, or condition, then we would get the entire column. But if we filter that column by a condition, say when a particular column is equal to a particular value, then we actually get hold of the row instead. Now, once you've gotten hold of the data in the row, you can actually go one step further, because we know that the row contains lots of data, right? What if we wanted that particular row's temperature or that particular row's condition? Well, let's say that we create a variable called Monday, which is equal to our data frame, and then searching through that data frame where the data.day is equal to Monday. So now with this row, Monday, we can then tap into the values under different columns by using the same kind of way that we got data in the entire column over here. So we can say Monday.condition, and if I print this out and just comment these other bits, then you can see that I get the actual condition for that particular day, which happens to be sunny. Now, here's a challenge. I want you to get Monday's temperature, but because my temperatures are in Celsius, I want you to convert it into Fahrenheit. So pause the video and see if you can complete that challenge. All right, we know we can get hold of Monday's temperature by saying Monday dot and then the name of that column in the row, which happens to be temp, T-E-M-P. Now, once we've got that temperature, we can convert it into a normal integer by wrapping the int around that value. And then if we want to convert Celsius to Fahrenheit, all we have to do is to multiply the Celsius by 9/5 and then add 32. So it'll be Monday temperature multiplied by 9 divided by 5 and then add 32. So Monday temp F, and then we can print this value out. So now when I run it, we get 53.6. And if I put Monday's temperature, 12, into this Google converter, I get the same value, 53.6. Now the final thing I want to show you is how you create a data frame from scratch. So in our case, we created our data frame by reading from our CSV file. But what if you wanted to create a data frame just from some data that you're generating in Python? Let's say that I have this dictionary of values. I've got some students, and these are their names held in a list, and then each of them has a score, and the scores correspond to the students. So 76 is Amy scored, James scored 56, and Angela scored 65. Now, how would we create a data frame from this dictionary? It's really simple. We call our Pandas library and we get hold of the data frame class. And then we initialize that class with some data. And the data in our case is just going to be our data dictionary. And now if I go ahead and save this as our data, so I'm going to comment out what we had previously and then print out this data, then you can see I've now created a table using the values from that dictionary. Now we can go even further than this. When we've created a data frame, we can actually get that data frame to be converted to a CSV file. And this toCSV method takes only one required input, which is the path that you want to save this file. So let's just create a new file, which we'll call new data.csv. And when I run this code, then watch over here, you see a new CSV file being created from thin air, and all of our data has been added to that CSV file. So we're just getting a glimpse into how powerful this Panda library can be. And we're only really using it to read CSV data and write CSV data, which is a common format that you'll see being manipulated using Python. In later lessons, we're going to dive deeper into data analysis, and we're going to be looking not only at Pandas, but we're also going to be looking at NumPy, Matplotlib, and other libraries that make it easier for us to work with large chunks of data. In the next lesson, we're going to be putting what we've learned to use by analyzing some squirrel data from Central Park. So for all of that and more, I'll see you on the next lesson. Now that you've learned how to do the basics of data analysis with Pandas, it's time to put your knowledge to the test. And we're going to be working with a really interesting data set. Back in 2018-2019, a bunch of volunteers went into New York Central Park and they basically combed the entire park to find all of the squirrels. So this resulted in a huge data set of squirrels, squirrel numbers, squirrel fur color, and a whole bunch of other things. And all of this data can be found on the New York City Open Data website, which we'll link to in the course resources. When you head over here, you can take a look at all of the data that they collected. If you take a look at all of the columns in this data set and click Show All, you can see they've logged the location of each of the squirrels, they gave each squirrel a unique ID, they evaluated whether if the squirrel was an adult or a juvenile, and they looked at what the primary fur color was. So it could be gray, cinnamon, which is red, or black. Now, if you scroll down, there's actually a really interesting visualization of this data where they've plotted all of the squirrels onto a map of Central Park. So you can take a look at the distribution of the squirrel population in Central Park. So you can see where the red squirrels are, where the gray ones are, and where the black ones are. So there's only 3 colors really. So what you're going to do is you're going to go to this website, click on Export, and download the CSV data. Now, once you do that, you'll end up with a 2018 Central Park squirrel data, like this. Now, you're going to pull that data into your Day 25 project folder and click Refactor to move it in. And you can see this is a lot bigger than what ever data we had before. There's thousands of entries, and it's actually real dedication that these volunteers went around logging all of this data, observing all the squirrels. It must have been a very tedious task. But now that somebody else has carried out the hard part, we can do some data analysis on that data. So I want you to comment out everything that you've got so far in your day 25 project. And the goal is for you to use that data and use what you've learned about pandas to be able to create a CSV that's called squirrel count, that has a small table which just contains the fur color. So there's only 3 fur colors and they're logged under the primary fur color column. And it can either basically be gray, cinnamon, which is red, or black. There's only 3 possible values in that column. Now, what you're going to do is you're going to figure out how many gray squirrels there are in total, how many cinnamon ones, and how many black ones based on that primary fur color column. And then you're going to take that data and build a new data frame from it, and using that, create this final CSV using pandas. Now that you know what you need to do, have a think about the problem and see if you can complete this challenge. Pause the video now. All right, if you've commented out the line where you've imported pandas, then you'll obviously have to do that again. So let's think about what we want to do. We want to isolate the column, which is the primary fur color. And if it helps you, you can actually better visualize the data on this website where they've got a table preview. So you can see that here is the primary fur color, and you can see the colors that have been logged. So our goal is to somehow get hold of this data series, which contains this entire column, figure out how many of them are gray, how many of them are black, and how many are cinnamon. How do we do this? Well, firstly, let's get hold of our data. So we're going to use our pandas.readCSV method, and then we're going to direct it towards this 2018 Central Park Squirrel Census data. Now, if you want, you can actually right-click, refactor, and rename it to something a little bit shorter. But because I know that PyCharm will actually fill this in for me, as long as I start out with a string and that file is in the same folder, it'll actually type it all out. If I just hit enter, then it doesn't really matter. But of course, make sure that you don't have any typos in here if you're typing it out, because otherwise when you hit run, you're going to get a whole bunch of error text inside your console. So once I've successfully read that CSV, I've now got a data frame. From that data frame, I can get hold of the column that I'm interested in, which is called primary fur color. Now, because it's got spaces, it's easier to access that data by using a square bracket and then putting in the name of that column like this. This is one of the methods that we showed you. Now, once I've gotten hold of that column, well, the next thing I need to do is to find all of the rows in that column where the data is equal to each of the colors. So there was the color, which is gray, so Gray, not EY. And then once we've got hold of all the gray squirrels, then we're going to pull that out from our data. So now we should have a bunch of gray squirrels. And it's probably a good idea to print them out just to see if that actually worked. And because I expect there'll be lots of rows with gray squirrels, it makes sense to make it a plural, gray squirrels. So now if I hit run, you can see listed here are all of the rows where it contains a gray squirrel. Now it's redacted this table so that it can actually display it in the console, because we know that there's many columns and there's many rows. It's just showing you the first few rows and then the last few rows, and also the first few columns and the last few columns. So we can be pretty sure that we've managed to get hold of all of the rows that contain gray squirrels as their primary fur color. Now, what if we wanted to know the gray squirrels count? Well, we could use our length method, because remember, once we get hold of the rows, it kind of gets treated a bit like a iterable, so like a list. And you can use methods like length on this data. So now if we print gray squirrels count, you can see that we've got a total of 2,473 gray squirrels. So now all I need to do is to repeat this process for the other colored squirrels. So I'm going to call it a red squirrel, even though theoretically their fur color is cinnamon. So I'm just going to copy and paste that in there in case I make any typos. And the final squirrel is the black squirrel. So those are all three squirrel types, and if I go ahead and print out all of these, so the red squirrel count, the black squirrel count, and the gray squirrel count, you can see that you've got mostly gray squirrels, a few red ones, and very rarely do you actually see a black squirrel. I certainly haven't seen one recently. Now that we've got our three values, it's time to construct our data frame. So to construct our data frame, the easiest way is to actually just create a dictionary. So I'm going to create a data dictionary, and this dictionary is going to have two key value pairs. So the first key is going to be the fur color, and this is going to contain the three fur colors, which is gray, cinnamon or red, and black. And then the next key value pair is going to be the count. So now we can create a list where the first value is going to be the gray squirrel count, next it's going to be the red squirrels count, and finally it's going to be the black squirrel count. So now that we've got our dictionary, and this is what it looks like, then we can go ahead and actually turn this into a data frame. So to do that, we need to get hold of the pandas and then get hold of the data frame class and then initialize it using this data dictionary. So I'm going to save that as df for data frame. And then the final thing I need to do is to get my df to convert to a CSV. So now I get to specify the name of the file, which I will call squirrel count.csv, and once I hit run, you'll see that new file show up right here, and you can see that it's constructed my new CSV file with all of the data that I've extracted from my Central Park squirrel census, and I've now got a new table with the data that I'm interested in. So did you manage to complete this challenge? If you found it tricky working with the data frames and figuring out how to get hold of the columns or how to get hold of the rows depending on the conditions we're interested in, then I strongly recommend to just head back to the last lesson. Just try to write out the code that we're doing in each step of the video yourself, just to make sure that you're 100% sure with what's going on. Once you're ready, head over to the next lesson. We're going to finally build our US states game. For all of that and more, I'll see you on the next lesson. All right, it's time to put some of the stuff that we've learned into practice. And the project that we're trying to build towards is a US states quiz. One of my favorite websites for quizzes is a website called Sporkle. And they specialize in quizzes that are basically just you making a list. And one of the best quizzes they have is the list of US states. You can head over to this link in the course resources and you can start playing this game. They're presuming that there's 50 states in the US, and every single time you type in the name of a state, then that state gets labeled and you score 1 point. The goal is to be able to name as many states as you can remember. This is basically the game that we're trying to replicate using Turtle and using some CSV data. And this is what the end result looks like. We've got a Turtle screen, which has a background that is an image of the US with all of the states blanked out. And what we're going to do is, by looking at the shape of the map and by remembering what the states look like, try to name as many as we can. And once we've entered the name and we hit OK, then if it actually exists, it gets added to the map. It seems simple, but the code is going to need some of the new things we learn about using data, especially data from CSVs. Now, the first thing I want you to do is to head over to the link in the course resources that takes you to the starting file for the US states game. Now, once you're here, you're going to fork your own copy of this project, and then you're going to click on these three dots at the top and then download this entire project as a zip file. Remember that you won't see this until you've forked the project. And also, if you're not logged in, then when you fork it, it's going to give you a random name, which means that when you download it as a zip, you'll have to rename that zip file to US States Game so that your project can have the correct name. So the easiest way, as always, is to just log in, fork a copy of the project, and then download it as a zip file. Once you've done that, then you can open it up inside PyCharm. And you can see that there's three files here. One is called 50states.csv, and this is a CSV file that contains all 50 states in the US by name, and then some X and Y values, which we'll talk about a little bit later on. The next thing you'll see is a blank states image.gif. Now, the reason why it's a .gif rather than a .png or .jpeg is actually because Turtle only works with this one image format. So in order to display an image, we actually need to convert the image to a GIF file, which I have done already. This file is just an image of all the states of the US blanked out, so it doesn't have the names. So it's ready for our user to start guessing. Finally, you'll have an empty main.py file, and this is where we're going to get started. So the first thing I'm going to do is I'm going to import Turtle, so straight up import the module, and then I'm going to create a screen object from turtle.screen class. Now, once I've got my screen, then I'm going to change the title of the project to the u.s.states.game. And finally, I'm going to get my screen to only exit on click. This is pretty basic. We've done this lots of times, but the next thing that we're going to do is a little bit new because we haven't actually worked with images in Turtle before. One of the things that you can do with Turtle is you can set the turtle's shape to a new shape. So you can set it to a circle, or you can set it to a square, etc. But you can actually load in a new image as a new shape. And the way you do that is you get hold of your screen object and you say add shape, and this shape can be any image file. So in our case, it's going to be the name of this file. So I'm going to create a new variable called image, and it's going to store the file name or the file path of my blank _states_img.gif. So this is basically the path to reach my image, and that is the shape that I'm going to load into my screen. So once I've added the shape to the screen, then it's now available to be used by a turtle. So I can say turtle.shape and change it, instead of to circle or square or turtle, I'm going to change it to this image file. So now when I run my project, you might, like I have here, get an error like this. Couldn't open this file because there's no such file or directory. This is really, really common, and it might happen to you. In this case, just be sure that whatever it is that you've typed here actually matches the name of your image. So as you can see, it's actually blank states_image, and I've only got state without the S. So now when we run this again, there should be no problems, and I can see the image show up here. Now that we've managed to load up our image onto our Turtle game, the next thing we want to do is to figure out the coordinates of each of these states. For example, if we wanted the word California to show up over here, then we need to know what is the X and Y coordinate of this location relative to the entire game screen. That way, when we actually guess a state like California and hit OK, it can actually show up with the text to be written on that state itself, so that the user knows which states they've guessed and which ones they still need to guess. But how would you place the text on a particular point of the map? How would you get the coordinates for this point? Well, after a quick search on Google, I find a Stack Overflow question that basically is trying to do exactly what we want. So this is the code that we would need. So let's go ahead and copy all of it and paste it into our project. Let's take a look through this code and understand what it's trying to do. So firstly, we've got a function here called getMouseClickCoordinate, and it takes two values as inputs, x and y, and then it prints those out. Next, we've got our turtle module calling onScreenClick, which is a event listener. So it's going to listen for when the mouse clicks, and then it's going to call our getMouseClickCoordinate function, and it's going to pass over the x and y coordinates of that click location. Finally, we've got this turtle.main loop. So this is an alternative way of keeping our screen open even though our code has finished running. So it's basically an alternative to our screen.exit on click. And in fact, if you think about it, if we wanted to get the click location and our screen exits as soon as we click on it, then it's not really going to work very easily. So we're going to delete this line and we're going to replace it with this turtle.main loop, which is going to keep our screen open. So if I comment out all of this previous code, and when I run my project, you can see it still keeps the window open, but without it, it's just going to flash up and disappear. While this code is running, if I click on one of the states, let's say where California is, you can see the X and Y values being printed in the console. So we can repeat this for all of the states on this image and get hold of where each state lies on this map relative to our turtle screen. Now, if that sounds really tedious, then I have to tell you it really is. But lucky for you, I've actually gone through this entire process and I've logged all of the X and Y values. Now, some of them may be a little bit off the center of the state, but you can always tweak this if you want to. But now you know where all of these X and Y values are coming from. So you don't actually need any of this code because we already have all of the X and Y values in our 50states.csv. All you have to do is to read from that CSV and get those X and Y values. And then you're going to ask the user for an answer, and we're going to do that through the use of an input. Remember, we can call screen.textInput to create one of those pop-up boxes, and we can give it a title, and we can also give it a prompt. So when I run this, you can see that this pop-up box looks like this. The title is at the top of the window and the prompt is inside the box. And once we type something in here, like Ohio, then I can actually get hold of what the user typed by tapping into this answer state. So if I go ahead and print it, then you can see it will be whatever it is I type into this box. So now you know what is the X and Y value of the location that we need to write our text for the name of the state that the user has guessed correctly. You also know how to get the user to enter a new answer through our text input. So in the next lesson, the challenge begins. And you're going to use everything you've learned so far in order to read from the CSV file and get the game to work. So for all of that and more, I'll see you there. All right, so in the last lesson, we did a lot of setup and we got our game to have the basic features. It's got a pop-up that asks us for a state's name. And when I type a name in here, I can receive it inside my code using this answer state. Now your job is to use that 50states.csv to check the user's answer against all of the states inside this table and see if it matches one of them. Now the user might spell it with a capital to begin with, say Ohio, or they might just write Ohio, and it should work for both of these cases. In addition, when the user types in a state that is inside that 50states.csv, then that state should be written onto the screen at the location where it exists. So remember, the location corresponds to the X and Y values that we've already logged inside this data file. But if the user guesses a state that's wrong, then nothing happens and our input box appears again asking for a new input. Now, notice how here in the title of the text input, I'm also keeping track of how many states they have guessed correctly out of 50. And every time they add a new state, then that number updates. This is going to rely on the knowledge that you've learned about reading from CSV data, getting hold of the specific parts of the CSV data, finding, for example, a particular row or a particular column, and working with that data in order to check to see if the user got the state right, and then using the data inside that row to figure out where to write some text at which X and Y location so that we can get the actual name of the state written at the location where they appear on the map. So this is quite a challenge, and I expect that you'll have to think about it and play around with the code for at least 10 to 20 minutes. So give it the time that it needs. Have a think about how you would break down this problem and try and complete this challenge. So pause the video now. All right, so I'm going to walk through the solution with you, but I want you to do a conscience check. If you haven't spent at least 20 minutes working on this problem, fixing it, getting it to do what you want it to do, then go back, try again. You need to feel the struggle in order to learn. I can tell you how to do anything, but if that answer didn't come from you, then you're not actually going to make progress. So I really, really urge you to give it a go before you watch the solution. All right, so back to our code. The first thing I'm going to do is I'm going to import the Pandas module. So I'm going to import Pandas. Now, I've already installed Pandas on the starting project that you downloaded, but if you're doing this completely from scratch, from your own starting file, then you'll probably get a red squiggly line under this Pandas and it'll ask you to install the package. But if you don't have it, then it means it's already installed and ready to use. Now we're going to get our Pandas to go ahead and read our CSV file. And the CSV file is called 50states.csv. So once the prompt comes up, then I'm going to hit enter to get PyCharm to just insert it automatically. Now I'm going to save that data frame that comes from that reading that CSV to a variable called data. Now our data has 50 rows of data, and the first row is the column headings for each of them. So we've got the state, the X and the Y values. Let's have a think about how we might break down this problem that we have. So when the user types an answer, we have to check to see if that answer state is one of the states in all the states of the 50 states CSV. The first column is a list of all 50 states. So if we could somehow check to see if this state that they've guessed is one of the states in that column, then we'd know whether if they got it right or wrong. If they got it right, then we need to figure out how we can create a turtle to write the name of the state at the state's X and Y coordinate. For example, if the user guessed South Carolina, and indeed South Carolina is one of the 50 states, then we should be able to pull out this entire row and then create a turtle, make it go to this X and Y location, and to write the name of the state onto this blank state image in our turtle game. Let's see if we can tackle this. Now, the first thing we need to figure out is how do we get hold of all the states of the 50 states CSV? So we've got our data frame, and if I go ahead and say data, then I can pull out one of the columns. So the column name is state, and I can either use that as a key with a set of square brackets, or I can use it as simply an attribute name. This gets me the data series, which is that first column. And if I want to be able to turn that into a list, remember that we saw that method toList. And that means we can work with it just like any other list. So let's call this all states. And once we've got hold of this all states, well, we can check to see if the answer state is in the all states. This is something that you won't be able to do, so checking for membership using the in keyword unless you have converted this into a list. So once we've figured out that this answer the user provided is in fact one of the states in our 50 states, then the next thing we need to do is to create a turtle. So let's create a new turtle, which we'll call T, and we're going to use the turtle.turtle class to construct it. And then we're going to get the turtle to hide the actual turtle shape. And we're also going to get it to pen up so that it doesn't actually do any drawing. But what we do need it to do is we need it to go to a particular X and Y location. The X and Y location is going to correspond to the state that the user has correctly guessed and the row of data from our 50states.csv. So how can we get hold of the actual row of data that corresponds to this state? Well, we can take our data and then inside some square brackets, we can check that the data.state is double equal to the answer state. This is going to pull out the row where the state is equal to the answer state. So I'm going to save that under something called state data. And now I can tell my turtle to go to state data.x and state data.y. So because this is a row of data, then I can tap into its attributes using the names of the columns, the X and the Y. And once my turtle gets there, then I want it to write the name of the state. So it's going to be state data.state. Now, when we hit run on this code and guess the name of a state that definitely exists, when we click OK, we're going to get an error. And it's really important that you get used to seeing errors because they're going to happen to you all the time. Just as in life, the only certainties are death and taxes. In programming, the only certainty is you will get bugs and you will get errors. The important thing is to figure out what's causing the error. So if we go ahead and copy this error at the end, bad screen distance, that seems to be telling us what is actually going on. And then I go into Google and I search for this particular error, then I can see other people who've encountered this issue. So if we read through all of this, between all of the subtext, it tells us that the issue is actually that our coordinates are stored as strings. We need to get the coordinates into actual numbers. So the one oversight that you might have made, which is really common, is to simply tell it to go to state data.x, state data.y without first converting them into integers. So now if we bring back our screen.exit on click and then run our code, we can type the name of the state, click OK, and you can see the state data show up on the location that corresponds to that particular state. Now, the only problem is we don't want all of this junk to be written here, right? And this is showing up because we're getting this data from our data series. So what's a much simpler way? Well, we've already got hold of the answer that the user typed, right? So why don't we just write the answer state? So now, when I type in the state and it matches one of the states in the 50 states, then it's going to go to the X and Y location of that state and print the name of the state that the user has typed in. And because we've made sure that it's a correct state with a correct spelling, then it doesn't actually matter if we use the answer state or if we use the state data. Now, if you really want to use state data instead of answer state, because say you're writing a different program and you need this functionality, then you can actually tap into state data.state, which will get us the state name from the row corresponding to the matching state. And then we can use a method called item. Now, item is a method on the Pandas series. So we know that this is a Panda data series, and you can do a type check on that if you want to confirm. But what the item does is it looks into the underlying data and it basically just grabs the first element. So now if I run the game as it is and I type in the name of a state, you can see it fetches the actual value under state data.state without any of the index, the zero, or any of the other parts of the data series. So I just wanted to show you that you can actually get a row of data from a data frame and then get a particular value from that row and get the actual raw value from that. But in this line of code, I prefer state because we know it's already been title cased, it's already formatted correctly, and it just makes the code look a bit cleaner and it's easier to understand. So I'm going to stick with this. So now that it's working, all we need to do is to get this to repeat itself every single time the user makes a new guess. That means we're probably going to have to put it inside some sort of while loop. What should be our while condition? Well, we know that the user is going to guess all of the states, and once they've guessed all of them, then they win, right? So why don't we create a list of guessed states and set that to equal an empty list, and we can check while the length of the guessed states is less than 50, then we can continue rerunning all of this code, getting them to put a new input, checking the input, and writing the state name. But every time the user guesses a state correctly, then we're going to add this answer state to the guessed state. So we can say guessed states.append, and then we're going to append this new answer state. So now when I run this code again, then you can see that every time I guess a new state, this text input pops up again, and I can basically just keep going until I've named all the states. Now, the next thing I want to change is the title of this text input window. Instead of saying guess the state, I want it to keep track of the number of states I've guessed correctly. So I basically want to say something like 0 or 10 or whatever out of 50 states correct. This 0 is going to be replaced by f string, and we're going to use the length of our guess states in order to get that number. So now when I run this code, you can see that I start out with 0 states, 0 out of 50, and every time I guess a new state, then it adds to that count, so I can keep track of how many I've guessed and how many I've got left. Now, the next thing you'll realize if you test this a few times is even if you get a state right, but if you actually didn't spell it with a capital C or capital letter to begin with, then it's not going to accept it. So we don't see California showing up. And this is because in our state data, they all have title case where the first is capitalized. So how can we make sure that our game works if the user types all lowercase or all uppercase or title case? As long as they got the spelling right, we should ignore the casing. So one way of doing this is to take this answer state, which comes from that text input that the user has entered, and then at the very end, we can change that to a title case. So this is a method that's on all strings. So that means if I start out with a string, which is Angela, and then I say string.title, then this will give me the same string back, but it'll make the first letter capitalized. This is what we're going to do to the user's answer. And then we'll be able to against all the states. And now it doesn't matter if the user has typed everything in all caps, or if they have typed it with all lowercase, or if they've done something really crazy like this, it will still be accepted. So we've now got most of the functionality of our game. In the next lesson, we're going to figure out how we can get this game to become more of an educational tool and for it to create a final CSV when we're ready to exit the game that's going to tell us all the states that we missed so that we can learn them, so that we can come back to the game with more knowledge. For all of that and more, I'll see you on the next lesson. So we've now got pretty much all the functionality that we want in order for this to function as a game. But if we want to be able to use this listening tool, then it would be great for us to be able to have some sort of way of typing an exit code. Say if I typed exit, then I could exit out of the game, and then I could get my code to generate a CSV file that contains all of the states that I missed from all 50 states. We know that in our while loop, we can exit out of it as long as we use the break statement. What we can do is we can use an if statement to check, well, if the answer state was actually equal to the secret code, which is exit. Remember that the answer state is going to be title cased, so we have to check for it with a capital E. And if that happens, then we're going to break out of our while loop, which means it's going to end the while loop prematurely. And we can delete this line so that it actually ends the game and exits out of the window. So if we test this out, then you can see we can type our states or we can type exit, and that will exit the game and we end up with process finish with exit code 0. This is the moment where we want to generate a new file. And that file is going to be called states2learn.csv. And I want you to generate this CSV, which is going to contain just the names of states which have not been guessed by the user when they exit the game. Have a think about how you would achieve this. Pause the video and give that a go. All right, so let's think about this. What we want to do is to take the guessed states and compare it against all states, and then we want to create a new list of all the missing states. So let's create a new list called missing states, and then we can use a for loop to loop through each of the states inside all of the states. And if we find that a state is not in the guessed states, well, then that means it's missing, right? So then we could tap into our missing states and append this state. And by the end of this, we should end up with a list of all of the missing states. So let's test this code. So I'm just going to type in a few states, some of the ones beginning with A. So Alaska, Arizona, Arkansas, and what's the last one? Alabama. Okay, so I think that's all of the states beginning with A. So now I'm going to hit exit, and it's going to give me a list of all the states that I'm missing. So if we take a look at all the A states, if we compare it against this list of 50 states, there's no Alabama, there's no Alaska, and there's no Arkansas because I guessed it correctly. So this is now just a list of all the ones I didn't manage to get. So now, how can we turn this list into a CSV? Well, we can create a new data, and that new data is going to be a data frame which is created from our missing states. So this is just going to be a one-column data frame. Once we've created that new data, then we can go ahead and save it as a CSV, and we're going to call that states2learn.csv, just as we've typed here. Now when I run this code and I've typed all of the A states and now I hit exit, then you can see we've got a new file that's just been generated, fresh out of the press, and it is our states to learn with all 44 states that I'm missing from my game. I hope you had fun building this game with me, and I would love to know how many states you can name the first time you play this game, because obviously the more you play it, the more you get better, And I hope you'll use this as an educational tool. If you have students, if you're a geography teacher, if you have kids, you can get them to play with this awesome program that you've built. Remember, what we've done here can be endlessly customized. You can make a version for your own country, or you can make one for the whole world where you have to name each country on the world map. Or you can do some other sort of list, like name all of the plants on an image, or name all of the animals. The world is really your oyster, and I can't wait to see what you've created using your imagination and how you've customized the code. So once you've done that, be sure to post it in the Q&A of this lesson, and so that we can all play and admire your code.